We talked about these yesterday when I talked about a scale factor. So a scale factor could be an enlargement where it's greater than 1, or it could be a reduction where it's less than 1. The algebraic representation is literally just putting that scale factor in front of the x and the y. As you move on in math, we can take the figure and do some strange things to it, like make the scale factor different for each. But right now, we're going to stick to the same scale factor. So we have the origin, and it's the center of dilation. You can find that by multiplying the x and y coordinates by the scale factor. So here's kind of the formula, and this got people in trouble with the other one because when we went to algebraic representations, I saw a lot of people put like x minus b, where b is the y coordinate, but or the difference in the y. But instead of doing it, they wrote b. So here is k, but k we're going to fill in for the scale factor, whatever it is. So we've got an image on a grid here. You guys have it, right? So first we're going to list the coordinates of the vertices of the preimage. That's this image right here. And I already got 1 is 2, 2. So that's this one right here, right?
Yeah.
You guys buy that?
Nope. Yeah.
Yes.
Yeah.
So Travis, what's this coordinate right here?
-2.
Is it -2? Remember, from the origin, left or right?
2, -2.
Is it -2? That's way down here.
Yeah, or negative, well, -1.
2, -1.
I should just not talk.
That's a mood.
All right, Trayson, how about this next point here?
That would be, that'd be 1, -1.
1, -1. Very good, sir. All right, this point right here, Joshua. 1, is it negative?
I'm -2.
So 1, -2. Moving over this way. Jason?
2,
What is it?
2, -2.
Is this 2? Here's 0. Which way am I going?
Left.
So what is this really?
2.
Think about it. It's negatives after the 0, right? If I go left. So -2,
And then 2.
-2. -2,
I can't
-2.
see that.
I can.
It's like blurry.
Better?
No.
Okay.
I'm gonna say
Let's look at this next point right here. Bryson, what's this point up here?
Where? Right there?
This point right here.
-2, 1.
-2, 1.
That was right.
Peyton, what's this point right here?
hang on. 1.
Think about it. X first, left and right. If it's left
1
of
and -1. No,
Th-
it's 1 and 1.
no. Look at the origin here at 0. Which way am I going?
-1.
Am I going to the right where the positive numbers or left where negative?
-2.
Negative what?
1.
-1, comma,
You switched them.
and then I go up, which puts me at
2.
1. All right, Elena, here's your chance. I know you were thinking about your point next.
No.
So, Elena, what's that point up there? That last point.
2.
Think about it. Start at the origin, left and right first.
Okay.
Am I going left or am I going right?
Is that a 1 right there? Is that a 1?
Yes.
I'm going left. That's negative numbers. I go left 1. So what is that?
-1.
-1. And then
2.
then 2. Yep.
Am I seeing both?
Okay. So the first step is to write down all the vertices and get them written. Let's go to the next step. The next set says list the coordinates of the vertices of the image in the second column of the table after dilation with the scale factor of 3. And you'll see up here, here's our rule. 3x, 3y. Does that make sense? So literally all we have to do is multiply each coordinate by 3. So in the first one they got 2, 2. They did it for you here. It says we multiplied 2 by 3 and we got,
6.
we did it same. So let's go back around, Travis. 2, negative 1.
Is 6, negative 3.
6, negative 3. Very good.
I did
All
it
right.
this time.
Trayson, 1, negative 1. Multiply both by 3.
Multiply both by 3 would be 3. Negative 3.
Very good.
Oh, so
Joshua, 1, negative 2. Multiplied by a scale factor of 3.
3, negative 6.
Very good. Jason, negative 2, negative 2. Multiplied by a scale factor of 3.
6, negative 6,
Negative 6, negative 6.
So negative
Are we following?
no, I'm confused.
What are you confused about? All I'm doing is applying the rule, this rule right here that says I multiply x times 3 and y times 3 to get my image coordinates. So Bryston's got this coordinate right here. Negative 2, comma 1.
Josh, do it.
When he multiplies negative 2 by 3, what does he get? Bryson, what do you get?
Negative 6. No, negative 4.
2. I'm going to move you guys.
Ladies.
Negative 2 times 3 is
Negative 6.
negative 6. And 1 times 3 is 3. All right, Elena. Negative 1, 1, and multiplying both by 3.
What?
Negative 1, our point is negative 1, comma 1. We multiply both by 3. What's negative 1 times 3?
Negative 3.
Negative 3. And what's 1 times 3? It's not negative. Positive 1 times positive 3.
Wait.
3.
The same, basically the same thing.
Okay.
It's 3.
Peyton, last point here. Negative 1, comma 2. Multiplying both by 3. What do you get?
Negative 3 and 6.
Okay. So now we can plot our points and get our large dilation. So let's plot our points. I've got 6, 6. That's way up here. I've got 3, negative 3. Where's my 3, negative 3? Oh, sorry. I got 6, negative 3. 6, negative 3. 3, negative 3. So I'm plotting and connecting as I go.
Negative 3.
Everyone following so far?
Yes.
Okay. Then I have 3, negative 6.
Okay,
Then negative 6, negative 6. Am I going too fast?
yeah.
Okay. I'll slow down, catch up.
Whoa.
I don't have the bottom one.
3. What?
All I'm doing is plotting the points off this that we made this column.
Look at Josh.
So right now, my last point was negative 6, comma negative 6. Then I have negative 6, 3. So far, so good? My next point is negative 3, 3.
Give her your hand, thanks.
She's saying that.
My last point is negative 3, 6. And then I connect all my points.
I don't know what you are anymore.
He's a teacher.
Well, duh. Obviously.
Okay.
Well, you said you didn't know, so I helped you.
So what did I do with my coordinates?
You connected?
You
I enlarged it, didn't I? I made a very large enlargement.
Did you know?
Yes, it's pretty much as big as it can get without going into decimals or fractions.
A little bigger.
Yeah, but it would require a decimal fraction.
You can go into decimal fraction.
We could, but we don't want to.
We should do that one day.
I will tell you that your project for this unit, and there's not a test for this one, there's actually a project, is really as easy as making your preimage, making your rules, drawing all your points, and then just plotting the points. The people who don't do that are the ones who are going to make the mistakes.
No, probably not one.
All right. So let's look at number 3 here.
Oh, my back.
It says graph the image of XYZ, triangle XYZ, after a dilation with a scale factor of 1/3 and the origin as its center. So we've got a scale factor of 1/3, which means we're going to multiply each coordinate by 1/3, or literally divide by 3. So let's go to this first one. What's the point of X right here?
that is 3.
3, 3.
3, comma 3.
I took you too long, Tracy.
I feel dumb.
Don't feel dumb.
Letting you do it.
So if I divide 3 by 3, what do I get?
0.
No,
1.
I get 1.
Oh, yeah.
So my new coordinate for X is 1, comma 1, right?
Yes.
So that's X apostrophe. Let's go up to Z here. What's the coordinates for point Z? Slow down. 3, because it's right from the origin 3, and then up to 9. So it's 3, 9.
But it's already on 9.
That's the point.
Oh.
We're just giving it a coordinate.
Oh.
Because remember,
I feel so stupid.
all I got to do right now is divide things, right?
Wait. So,
What's 3 divided by 3?
easy. 3 divided by 3 is 3.
No.
What? It's 1.
It is 1. So my new point would be 1, and what's 9 divided by 3?
3.
3. So my new point would be 1, 3. So that's Z right there. That's Z apostrophe.
On 3.
Mm-hmm.
What?
Remember, we divided each by 3, right?
Yeah.
So 3 divided by 3 is 1. 9 divided by 3, so 1. And 9 divided by 3 is 3. So our new point for Z apostrophe was 1, comma 3. Let's go to Y. Okay, as Travis said, it's 9, comma 9. So, dividing each by 3. What's 9 divided by 3?
9 divided by 3 is 3.
So 3, and they're both 9, so I'm not going to ask that question again. So Y asterisk will be 3, 3. So I go 3, 3. It's the same point as X, right?
Yeah.
And I'm just going to make it also Y apostrophe, and then I'll connect my little triangle. My triangle is 1/3 the size of the big triangle. Are they still similar? Yes. Are they congruent? What does congruent mean?
Same size.
The same, exactly. They're not congruent. Let's look at number 4 is the last thing. It says, write an algebraic rule to describe the dilation. Just like before, our algebraic rule is x comma y becomes,
Ow.
what are we doing to each coordinate?
Dividing.
Or we usually just say multiply by 3.
Oh.
You could write x over 3 if you wanted to, but it gets a little more complicated than 1/3. So 1/3 x and 1/3 y. That's a rule. Now, I want you to think about some of these rules. Could I rotate and dilate a figure at the
Yes.
same time?
Yes.
Yeah, just by adding the rules. If I wanted to rotate this, let's say clockwise, I would just make it negative 1/3 y, comma 1/3 x. And I do both at the very same moment. I could rotate and dilate all at the same time. Does that make sense?
Totally.
So you can do multiple of these functions adding together, and that's where you're going to take this eventually, is you're going to get to those complex.
That-
And the way to solve those is to do them piece by piece. Do the first one and then add the second to it. Any questions on dilation?
No.
Good.